Part 2, so to speak. There's several examples. Honestly, I'm just going to look at example 1 because I think that's enough to, we're trying to look at some applications of trig. It's enough to get us a taste of it and look at it a little bit there. So, if you recall, we were talking about vectors last Thursday and Friday, right? We looked at how to find the magnitude of a vector, the length of a vector. You can always flip back if you don't remember. We talked about component form. We added in linear combination, which is just another form of the component form on Friday. And we talked about the unit vector at one point, yes? We added vectors, we multiplied by a scalar. I'm trying to think of all the different things we've done. So, vectors directly relate to velocity, and that's the connection that we are making today. So, velocity of a moving object is a vector because velocity has both magnitude and direction. And when we define a vector, we talk about a vector has magnitude and both magnitude and direction. Now, when we learned magnitude last week, what did we talk about magnitude as? Okay, absolute value of v, and another word for magnitude was the length, right? The length of the vector. So here you'll notice the magnitude of velocity is speed. So when we talk about the magnitude of a vector in relation to velocity, we're talking about speed, okay? And then force. Force is a vector's magnitude. Okay. Example 1. Okay. A DC-10 jet aircraft is flying on a bearing of 65 degrees at 500 miles per hour. Find the component form of the velocity of the airplane. And note here in parentheses, the bearing of the airplane is the angle that the line of travel makes with due north, measured clockwise. Now, probably the hardest part about this is you have to forget the unit circle for a moment. Okay? Because our unit circle, where is our 0 degrees? At 3 o'clock, right? Now, our 0 degrees is north. So now you have to think in terms of a compass. And you also have to go the opposite direction. Okay? So, okay. Let's start with the picture, maybe. Nothing fancy here. A DC jet aircraft is flying on a bearing of 65 degrees at 500 miles per hour. Now, notice it says the bearing of an airplane is the angle that the line of travel makes with due north. So, obviously, maybe not obviously, I drew that arrow in to be north. Okay? So it says 65 degrees is the bearing. Notice it's the line of travel makes with due north measured clockwise. So 65 degrees from here is going to be where? From north, going clockwise, 65 degrees is going to end up over here somewhere? Ish. Okay. And so the idea here, that right there is 65 degrees, correct? And obviously notice with that 65 degrees, I stopped before I hit the x-axis, because what would the x-axis be here? 90 degrees, right? So putting that into basically a first quadrant setup, I stopped there before I hit that 90 degrees. Now, the jet is represented by the vector, and we also had that the jet is flying at 500 miles per hour. Okay. The directions asked us to find component form. Was it Friday? It was Friday. After we talked about linear combination, we talked about component form. and we talked about the horizontal and the vertical component, yes? So what do you remember about the horizontal and vertical component? Yeah. Horizontal was the magnitude or the absolute value of V times cosine of theta, and the vertical was the magnitude or absolute value of V times sine theta. That was something we learned Friday, and those were our horizontal and vertical components. So our job is to find component form. That's what we can use to fill it in. Now, before we can do component form, what's something we have to know? We're going to have to know the magnitude, aren't we? That absolute value of V is the magnitude. Okay, the magnitude, if you look up above, it said the magnitude of velocity is speed. Were we given a speed? Yes, 500 miles per hour is clearly a speed. So our magnitude is 500 miles per hour. Because up above, magnitude of velocity equals speed. So that means when we fill in absolute value of V, we're going to be filling in 500. Now, there's one other piece of information we have to talk about. Besides the magnitude, absolute value of V, we also have to know theta, which if you recall from Friday, I talked about theta and I called it the direction angle. I think isn't that what it was called? Try to remember the correct vocabulary. Yeah, direction angle. Now, if you flip back to Friday, notice how direction angle is defined. The direction angle of a vector V is the angle theta that the vector makes with the positive side of the x-axis. It's as simple as what? Yes. But the point is my theta 65? No, because that's not an angle with the x-axis. What we need to know is, what is this angle right here? That's my direction angle, my theta. And so, using logic, using math, yes, it is as simple as doing 90 minus 65, which is 25 degrees. It's just that a bearing is not the same thing as a direction angle. Okay, so now we can work to find our component form. In order to do the first component, or what we called A, we're going to do absolute value of V times cosine of 25 degrees. So 500 times cosine of 25 degrees. Your calculator is going to give you some magic answer, right? What kind of angle is it? So we're in degrees, yes. So 500 times cosine of 25 degrees is 453.15 or 0.2. Okay. In order to find B, okay, it's the magnitude times sine of theta, so it's going to be 500 times sine of 25 degrees. Again, let the calculator work its magic. 500 times sine of 25. Yeah. If I go 3 decimal places again, 211.31. So directions asked for component form. So that means my component form is 453.15, comma 211.31. You can put it straight into component form. Now, as we think about this, notice where my jet is going, yes? What direction would you call that if you think about a compass? Northeast? Okay. So, this 453.15, which direction is that? If that is my x-axis, that is the eastward. Okay, and so the idea is that this jet is going, and technically this is miles per hour, 453 miles per hour in an eastward direction and 211.31 miles per hour in a northward direction. Northerly direction? Northern? I don't know. I have eastward and northward written down, which I'm guessing I got that from the book, but yeah, it does sound kind of, you know. You get the idea. But the idea is that there is there's two components here. Together, they make the northeast, but individually, you've got the north and the east separately. Okay? So 41 and 42 should be like this problem we just did here. Now, I have lost it, it appears. Aha, maybe. The full homework you should have complete, or you will be complete, is page 464, 5 through 8, 13 through 20, 25 through 34. That's the same stuff I put up Thursday, right? I put it up again Friday. I'm putting it up again today. 41 and 42 I added in on Friday, I believe. Yes? Okay. So that is the full homework that is due. If you have the rest done, doing 41 and 42 won't be too bad to add on. And I would say you can go ahead and start working on that right now while I get my next step organized.